Hey there! Today your mission is to tell rational numbers from irrational ones. Rational means it can be written as a fraction. A over B, where A and B are integers and B is not 0. Integers are rational too because each can be written over 1. 5 is 5 over 1, -12 is -12 over 1. Fractions like 1/2, 3/4, and -17/8 are all rational. Decimals are rational if they terminate or repeat. Terminating example: 0.75 equals 3/4. 0.2 is 2/10, which simplifies to 1/5. Repeating example: 0.3 repeating equals 1/3. 0.36 repeating equals 4/11. Irrational numbers cannot be written as a fraction of integers. Their decimal goes on forever without repeating a pattern. Famous example: pi. 3.14 and 22/7 are only approximations. Square roots can be rational or irrational, so be careful. Square root of a perfect square is an integer, so rational. Square root of 2 is irrational. Its decimal never repeats. Same idea for square root of 3, 5, 10, and any non-perfect square. Spot check a decimal. Does it end or repeat? If the answers are both no, it is irrational. If it ends or repeats, it is rational. Two-fifths is rational. 0.16 repeating is rational. Square root of 7 is irrational. Square root of 16 is 4, rational. Perfect squares simplify to integers. Non-perfect squares do not. Rational numbers: integers, fractions, and decimals that terminate or repeat. Irrational: decimals that never end and never repeat, like pi and roots of non-perfect squares. Use fraction form and decimal behavior to spot which team any number is on. Ready to see what happens when these numbers combine? Let's talk closure under addition and multiplication. A set is closed under an operation if combining any two members stays in the set. Think, two members team up, and the result is still allowed inside. Rational plus rational is rational. 1/2 plus 3/4 equals 5/4. 5 plus 0.25 is 5.25, a terminating decimal, so rational. Rationals are closed under addition. Rational times rational is rational. 2/3 times 1/5 equals 2/15. -4 times 1/3 is -4/3, still rational. Rationals are closed under multiplication. Rational plus irrational is always irrational. If 5 plus root 2 were rational, root 2 would be rational. This is a contradiction, which shows the sum is irrational. Examples: 3 plus pi, 1/2 plus root 7, -10 plus root 3 are all irrational. A non-zero rationale times an irrational is irrational. 1/2 times root 2 stays irrational. Exception: multiply by 0 and you get 0, which is rational. Irrational plus irrational can be irrational, like root 2 plus root 3. But it can also be rational. Root 2 plus -root 2 equals 0, so you must check the specific pair. Irrational times irrational can be irrational. Root 2 times root 3 equals root 6, or it can be rational. Root 2 times root 8 equals 4. Addition: rational plus rational gives rational. Rational plus irrational gives irrational. Irrational plus irrational could be either. Multiplication: rational times rational gives rational. Non-zero rational times irrational gives irrational. Irrational times irrational could be either. 0 times anything is 0, rational. Closure means predictability. Working only with rationals under addition and multiplication keeps you inside the rational set. When radicals or pi appear, expect irrational outcomes unless simplifications make them rational. Ask, can I write it as a fraction? Does the decimal end or repeat? Perfect square roots become integers, others are irrational. Use these checks and closure rules to predict sums and products with confidence. You've got this. Keep practicing and the patterns will feel natural.